Right. So I want to talk to you all about ASCII. Just what is ASCII? Okay. ASCII is the American Standard Code. American Standard Code for information interchange. Okay. And what ASCII does is ASCII essentially allows for the translation of data into a format that can be transmitted by computers. So we know we have the alphabet, and each character in the alphabet, along with special characters and numerals, have an ASCII value. So I'm going to ask you all to do an exercise for me. I'm going to ask you guys to open Notepad, hold down the Alt key on your notepad and type 45. Right, not 45, 48. And then release the Alt key. And you'll notice that the number 0 comes out. If you hold down the Alt key on the keyboard and you type the number 65, you get a capital A. If you hold down the Alt key on the keyboard and you type 97, you get a common A. All right? What does this mean? It means that there are values assigned to particular characters. So the character 0, the value for that is 48. The character 65 is, the character A, capital A, has a value of 65. And the character common A has a value of 97. These are the ASCII values for these characters. And what this allows us to do is this essentially says when you have a O, or you have a stream of words on a computer system, the computer system gets a binary string. So allow me to go to my calculator, and if I type in 48 here, the binary value of 48 is 1100110000. So this here, essentially, when you have a character O, this is how a character O is represented on your computer system. If it is that you have the value of 65, right? 01000001. This is the value of an A on your computer, right? 97. 01100001. That's the value for an A on the computer system. So this is how data is translated. All right. When we have characters on your computer system are essentially stored and transmitted as sequence of bits. And when the computer system is prepared to read this, it knows that when it gets these particular values, that you have, you have the ability to convert this value back to its character representation. So what does this mean for us in programming? It means that we could do a couple pretty cool things. Okay? And it means that we can, now allow for confusion of numbers to take place. It means that we can now, use methods to encrypt data, because if it is now we convert a number to its ASCII value and then do some sort of calculation on it, then we could then use it to convert it into a format that somebody can't read, and then when the person gets it on the other side, we could convert it back. Okay? It allows for manipulation of data in special ways. it also shows that there's a relationship between characters and integers. So if it is, let's say for instance, I go to my code and I name this code ASCII convert.c, and I can't put a space in between, right? So we have include stdlib.h and include stdio.h int main turn 0. Let's say, for instance, we want to write a C program that shows all characters and their ASCII values, right? And some of these ASCII values are they're invisible, and some of them are like sounds. And one of them is a backspace. So, we're not going to be able to see all the ASCII values. Some of the early ASCII values are invisible and they're backspace, etc. Right? But let's just say we have char ch, and we have int I. And we say for, and I believe that there are 255 different ASCII values. So we could say for I is equal to 0, semicolon, I is less than 256, semicolon, I plus plus, and we want to show the ASCII representation. Actually, I don't need this char ch. This ASCII representation of a particular number, I could say printf %sign d or %sign d as %sign c is ASCII value is %sign d. And remember that same typecast I showed earlier? We could use a typecast to change that value of I, that numeric value of I, to a character value of I, which would do an ASCII conversion for us. And then we can show the actual numeric character that it's associated with. And we can put that \n there. So even \n and all, I think, is a particular ASCII value. So if I run this, right, I don't know if you heard the beep on my computer, but we have a whole bunch of characters here. And a lot of these characters, so this is, I believe, this might be tab here. We have some smiley faces, some card symbols. We have male and female symbol, a music symbol. I believe this one here is backspace. So 13 is backspace, right? If I open, is my notepad open? Right, let me see if I type some stuff and press 13. Oh no, I'm getting some different values when I do it in Notepad. But in the console, it looks like it might have been backspace for 13, or maybe it was 10. Let me see. Oh, 10, I'm getting some weird values too. So it might convert 1 to 1. Okay, so if we go over to 48, 48 is the character 0, 49 is the character 1, right? And that goes up to 57. Look, we established here that A is 65. And of course, that will carry us down to Z, which is 90. And then again, A starts up at 97. All right, so we have a whole bunch of ASCII characters, and then we have some special characters that we see in different languages. And then we might see things that we can utilize as borders. So if ever you notice that if you're really interested in doing it, you could draw a border around your text and stuff like that in C. Okay.
That's real cool, see.
Yeah, there's a way to do it. I never took the time to memorize how to do it, but I have had friends that like drew borders and then their commands to move the cursor back so that you could put text inside the borders and stuff like that. All right. So it's there to play with. So you can play with it. It's just something that you can know. So, let's say for instance we want to convert like a character from common to capital, and we'll see it now as we go and talk about strings, even though we don't have much time left in the class, right? Um, a string, let me get into strings and then we'll get back to that conversion. A string is essentially a character array. Okay, so a string in C is a character array. But a string could also be represented not in the same manner that we've been representing integer arrays, but a string could be represented using, of course, the quotes as values. So there are two ways that we could represent strings in C. We could think of a string as, let's say for instance, example, we have char str, and we have char str is equal to hello hello class. Okay, and this string, the size of the string will be defined by, of course, how much it was here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters in the string. If I have to visualize the string, it'll look like an array, right? It'll look like an array, str. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it will have a subscript just like an array too. And each element will hold a character. So this will hold the character H, this will hold the character E, this will hold the character L, this will hold the character L, this is the character O. It will hold the character space, common C, L, A, S, S. And at the end here, there's a special character called \0. And this character, right, is really important to strings. This is the string termination character. And what this is it's \0. It's another two-part character. But it is a single character because it has that backslash on it, \0. And what it does is that it indicates to me where a string ends. In the same way, if I had this same thing, example, char, and I said str, and I gave the str a size, 30 is equal to hello class, right? I would essentially have the same thing like this. I'd have the same thing like this, except it will go all the way up to 30. It'll go all the way up to 30. Dot, dot, dot. This is 12, 13, 14, right? 29, 28, 27. But this same \0 here would indicate to me that the string stops here. So that if I use the %S placeholder, if I say printf, right, %S, and I go str, right, my output of this, would be the words hello class. And only that. Everything else in the string, everything else here is going to be ignored because of this \0 character. Are you folks with me?
A quick question, right, sir?
Hmm?
Oh, Kian, you have something to say? My bad.
No. Oh, somebody else needs to talk?
Yeah, I think Kian was saying something.
Here?
I wasn't saying anything, sir.
Oh, okay,
Oh,
my I was asking like the \O, right, sir?
\0.
Oh, \0, sorry. That is like understood when you press enter or something like that.
Yes, when you enter in a string, yes.
So we don't need to put in the \O or anything
No,
like
no. And it's a good thing you asked because I was now about to illustrate it. Okay, so let's take a look at a function called string.c, right? Well, let me name it first string.c. And what I want to do here is I want to write a C program that allows us to enter a string and print it out. All right? So we want to enter a string and print it out. And so we have int main. I have to put my includes, excuse me. All right. Sorry about that. You know, I really should I really should dedicate somebody every class to start writing the code for us now. Y'all don't feel that's a good idea?
that. So we are getting more practice that way, you know?
Yeah. So somebody from now on, I feel next to me doing that. Somebody sharing the screen and they writing the code and we watching the code as they write it. Okay. I feel a little fed up of watching my code too. Right? And watching Sir make a set of mistakes and all kind of thing. They don't find that.
So they ever watch me make mistake? Nah. I good.
I feel when you used to be like an OC, like, wait, this man typing this code real fast, like what?
Nah. You all find this type fast?
Yeah, you just type code like if it's a Word document. I don't know what you expect from we.
Well, I expect that from a too. Alright. We'll see. We'll see how it goes. We'll see how it goes. Okay. All right. All right. Int, not int, sorry. Char. So this is how we will declare a string. We could declare a string of as a character array of a particular size. So I could say char str, and my string could be 50 characters long. Okay, so this creates a string that can hold 50 characters. And essentially, if I printf to the user and say, hey, please enter, let's say, please enter a string or please enter a sentence. Please enter a sentence. I don't use scanf. I could use scanf, but scanf has limitations in terms of entering a string. I can use the function gets, and gets is not the best function to use, but it's good enough for us for right now, right? The actual proper one to use is fgets. Fgets has a couple more rules basically. So we'll use gets for now. All right, and we say get str, and this will take the user's string in from the keyboard. So this will take the user string in from the keyboard, and then if I want to say printf, and I could say the string you entered is, and I'll put it in single quotes, %s. And if I print back out str, whatever the user entered should be inside of that string. Okay, let's see if this works. So please enter a sentence. I enter the rain in Spain. And I get back the string you entered is the rain in Spain. Now notice that the placeholder for strings when printing out is %s. Okay? But we can also treat, so this is if we want to print out all of the contents of a string as a, as a whole sentence. We could also treat the string, so this is treating it like a string. But you could also treat the string as a what you call it? As an array. Okay, as a character array. And this is where I will end with you all today after this showing you on this. Int I. Okay, and I could start off I equal to 0. And I could say printf, not printf, I could say while str at position I is unequal to \0, right? So while we are not at the end of string character, while we have not met the end of string character, right? The end of string character to treat a string like an array, or like the array that it is, we could then go printf %C str at position I, and go I plus plus, right? And this will, let's say printf we now print your string as an array. Okay, and what happens now is that I print it out like I would have done for a numeric array. I print it out location by location. And I have to use the %C, because what this is this is now, let's say, for instance, here I entered hello in that string initially here. It prints out this here, looking at it as the whole hello. But if it is that I do this, it looks at it as this. HELLO, with a bunch of characters in the same variable. It's the same, It's the same, but conceptually, it's different. You all understand? You all get what I'm saying here?
Kind of.
Right? In one instance, you're treating it character by character. In another instance, you're treating it as a string, as a contiguous string of characters. That's one variable. In this second instance, you're treating it like an array, a series of elements. So if it is that I decide that I am going to go this route, and there are some instances where when you're manipulating a string, you might have to treat it like the array that it is. This is what you will have to do. So if it is that I go and I print out in both instances, the same thing is going to print out, but we've printed it out in different ways, right? So this is my string. So the string you entered is, this is my string, and this is supposed to be now. We now print out your string as an array. This is my string. But this way, I'm printing it out as character, 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 etc. This one, I printed it out as an entire string. But at the end of the day, the result is the same. But the knowledge is in you knowing as the programmer, you know which approach you took. Okay? Any questions so far? Any questions? No questions? Everybody's fine?
Yeah, I have a question, right? So, like I watch some YouTube videos and stuff, right? And like in those videos, like they don't have, well, they did it like they scan it, I think. And
With the string?
yes, sir.
Okay.
But in those cases, it doesn't let you put spaces in it. If you know what
Exactly.
So this way you can always get this.
Right. So that's what gets is not the recommended function for getting multiple variables. I didn't want to get into that because of the time constraint. But I think that maybe when next we meet, Tuesday maybe, cough, right? We can talk about the difference between gets and fgets and scanf for strings. Okay? Because of the fact that they have some differences between them. Fgets is really the best to use, in my opinion. Gets is good, but it's Linux doesn't allow you to use gets at all, right? So if you have, I don't know if on your Mac system, if gets would be used, or if you would have to use fgets. With fgets, you would have to do a little extra work because fgets actually captures the \n when you hit the enter. Okay, so you have to strip off that. And scanf only allows you to enter up until a space. So if you have multiple words, scanf is good for like reading data that is, let me say, granular. But if it is that you have to split up, or if you have some of that data with spaces in between it, you can run into trouble with scanf. So scanf has a particular application. All right. And actually, this will transfer over to when we start to read stuff in from files, where we have to as well, I like to allow what is the almost equivalent of fgets when you read it in from a file rather than fscanf, because you run into that same problem too, where if you have data that is treated as one, but it's separated by a space, then you can run into some issues there. Okay, but we have a long road to go with it, and I think that we are doing well for time. So we will address those when we get there. But the next class, maybe we could take a look at the difference between fgets, scanf, And what was the next? Yes. All right. Any other questions? No other questions? All right, before we go, let me just check in with some people. Dalrymple, are you there? Where is Brandon? Nissa, how are we doing?
Okay, sir.
Okay.
Yeah.
All right. Jarrell,
Yes, I inside. Look going good.
all right, good, good. Alexandra, Alexandra, you there? Okay. Jeremy,
Good, sir. Good.
all right. And Keishan,
Decently well, sir.
you doing well? All right.
Yes.
So, good, good.